We begin chapter 7, 3 sections here to finish off the course. So what is it? It's multivariable calculus, which might sound a bit intimidating. We're going to focus completely on derivatives. You will see multivariable integrals when you go to Math 122, and quite a bit more on integration when you get there. We are done with integration in what we did in chapters 5 and 6. So we wrap up this course with multivariable derivatives. So we'll begin just with an introduction. In 7.1, we actually don't do any calculus or derivatives at all. We just introduce what a function of several variables would be, multivariables. So 7.1, functions of several variables. I'm just going to begin with an example. And we'll take a look at this. I feel this stuff is pretty intuitive. This is a short section just to get us warmed up. So, for example, consider this function of x and y. So we say f of x comma y, and then the equation, of course, will involve both x's and y's. So this one, I thought this would be good. 3x squared y plus 5x minus 7y. Okay, so what might we do with that? Well, first we just want to present it. We probably never thought of a function of having two variables in it before. We're going to evaluate this function just for several different angles. So we'll begin with this part A. Find f of 2 comma 1. And well, I probably don't even need to write this part at the bottom. For f of 2 comma 1, we're thinking of the x as being a 2, the y as being a 1, and just like a regular function, we're just going to plug those in. So what does that look like here? f2 comma 1, f of 2 comma 1, 3 times 2 squared times 1 plus 5 times 2 minus 7 times 1. Okay, again, the x is 2, the y is 1. Plug it all in. And in this case, well, you get 15. 3 times 4 times 1 is 12. Plus 10, 22, minus the 7 gives you the 15. So you'll see a lot of these questions where you're just plugging numbers in. You're just getting familiar with these. What else might we see? Well, we can mix it up a little bit. Hey, same function. Let me try to keep that on the screen if I can. Find f of x comma negative 4. Okay, well, what does that mean? So we're going to keep x as just the variable x. So that's not going to change. The y is going to become negative 4. So, okay, it's almost like you're plugging in x for x. So you're not changing that, and only the y. So what happens? Well, if only the y's become negative 4, 3x squared times negative 4 plus 5x minus 7 times negative 4. And what are we going to get? Negative 12x squared plus 5x plus 28. Okay, again, kind of unusual. You're keeping one, you're plugging a number for the other, but all right, we get that. We can do that. I've got one more of these. How about find f of x comma x? So what is all this? Well, just like in the last problem, x stays the same, but now even the y's become x's. So you're replacing the y's with x. What's going to happen there? Well, f of x comma x, 3x squared, and now this y became an x, plus 5x minus 7, and that y became an x. And what do you get? F of x comma x, 3x to the third minus 2x when you simplify. Okay. So that's really the majority of the questions you'll see are going to be, things like that example. I'm going to present just one application here, and that's going to do it for 7.1, just the one video. So here we go. It's kind of got quite an introduction. For example, a company produces two types of bicycles, type A and type B. The demand equations are, price demand equations, are these. So what's going on? So imagine, I think I've got it all, yeah, where this such and such. Okay, I should probably show you all this. So these are the two price demand equations. P is the price of type A, Q is the price of type B. So that's how much we're going to charge for each type of bicycle. X is the number of type A that we're going to sell. So you'd say that's the demand of type A. Y is the demand of type B. It's how many of those types of bicycles we're going to sell. So the price of each is connected to both sales, right? So how I determine the price for type A not only depends on how many of type A I sell, but it also depends a little bit on how many of type B I sell, because maybe if I sell more of B, that means I should lower the price on A, or perhaps even if I sell more of B, I should raise the price of type A. You know, somehow these are connected. We don't have to know all the details. Okay, so what are they going to ask us to do? Well, it's really kind of like what we just saw in the previous problem, just now we have a context. We're going to find the revenue if 10 type A and 15 type B are sold. So we know values of X, that's an X. How many of type A are sold? That is a Y. So we know we'll plug in 10 for X and 15 for Y. But wait a second, there's a little bit more to it. Find the revenue. And we were given the price demand equations. Do you remember how we find revenue in the single variable case? So let me try and keep some stuff on the screen. So this was revenue in single variable. We at least saw that. I remember this coming up back in optimization. We had to create a revenue equation given a price demand equation. So what is this all about? Let's just remember, why is it X times P? Well, X is how many you sell and P is the price. So however many you sell multiplied by the price, obviously that's how much money you bring in. What's that going to look like if we have two of them? Well, we need to do it. I think I definitely got to bring this up off the screen. We need to do it for both and then add them together. So this is the multivariable revenue. R of xy will take X times P and also add it with Y times Q. So however many of type A we sell multiplied by the price of type A plus however many of type B we sell multiplied by the price of type B. Total revenue for all of it. Once we have that two variable equation, then we'll plug in our 10 and 15. So we're going to plug in the P, we're going to plug in the Q. All right, P was equal to 230 minus 9x plus y. Q was 130 plus x minus 4y. So we can put all that in. Now we only have x's and y's. We'll go ahead and simplify this first. Truth is, you could plug in your numbers right here, since that's all we're after. But I'm going to go ahead and simplify that and multiply it out. Okay, so let's see, x times 230, okay, minus 9x squared. That's plus xy. Then you notice we have another x times y here, so plus 2xy. Y times 130 minus 4y squared. And at this point, we can plug in our 10 and our 15. And I just went for it. X equals 10, y equals 15 will give you 2,750. That is the total revenue from sales of type A and type B bicycles. Well, that is it for 7.1. Go check out the homework and 7.2.